So today we are going to start with the experiment. We want to find out the frequency of our AC mains, which should be about 50 Hertz, using electric vibrator and a vibrating string. So you already now know about the direct current and alternating current. So let me define these two. An alternating current is an electric current whose magnitude and direction vary cyclically, as opposed to direct current whose direction remain constant. The usually waveform of AC current, AC power circuit is in sine wave. And what we know about the direct current, which is electricity flowing in a constant direction and possessing a voltage with constant polarity. DC is a kind of electricity made by a battery and a kind of charge we can say generated by the rubbing certain types of materials against each other. So I'm not going to waste my time to define these two more. So let's start to our main topic. So let me define the diagram of this experiment. Here is the main diagram which we can use in our laboratory work to do the experiment. So this is an electric vibrator, and you already know about the electric vibrator. So let me tell you about the electric vibrator. An electric vibrator is and consists of solenoid. This is an solenoid and a thin steel rod. So from here to here, this is a steel which is binding screw held it here and other side is free. The free end of the rod is slightly flattened and a hole is drilled in it which is binding by this thread and other side is hanged by a pen. So how it's work? When an AC current pass through the vibrator, when this AC current is passed through the vibrator, its rod start vibrating with the same frequency. This rod will vibrate with the same frequency as the AC mains. If we tie a thread, here we tie this thread we are going to tie here, and the other side of this thread we hang a pen here. The string will also vibrate. So this string will going to also vibrate. When the conditions are correct, stationary waves form in the string. These waves shows loops and nodes. Let me show how which kind of loop they will going to show here. The sine wave. Now the actual waveform in the visualized manner you can see here. The string will going to vibrate in this motion, in the sine wave motion, and it will going to create the loops. The frequency is totally depend on the weight that you are going to put in this pen. In this pen, I'm going to explain the calculation as well in the further in this video. So let me tell you about the procedure how it's work. Fix one end of the string to vibrator here and pass other over pulley with the pen here. This is pulley, frictionless pulley. So put weight in pen to make the string tight. When you are going to put in weight, here you can see the weight is already shown in this picture. So switch on the AC. When you are going to switch on the AC to flow through the rod vibrate to make the vibrator rod vibrates, adjust weight until the clear the loops. When you are going to put the weight, you can see some kind of frequency in this string, and we are going to put weight again and again, and you can see the loops going to create in this row. Adjust weight until clear loops form a string. Find loop length. Now the loop length, how you can calculate, I'm going to tell you in the further in this video in the calculation part. Calculate the mass per unit length, and with using the formula of the tension we can going to calculate the frequency. So by measuring the length of these loops and knowing the tension and the mass per unit length of the string, we can calculate the frequency. So here is the observation table, how you can find these values, these reading and calculate the frequency. So I'm going to tell I have already calculated with my own self, and here it is. So these 4 to 5 values are constant. We are not going to change further these values. Mass of the mass of the thread, length of the thread, mass per unit length m, empty pen mass, and g, gravity of mass. So mass of thread is 1 gram, that is constant. Length, which length? I think you are already know which length I'm going to talk about. So this length here, from here to here, the length of the thread. Now mass per unit length is 0.001 kg per meter. Empty pen mass. When pen is empty, we have to measure the weight, that is 20 gram, which is 0.02 gram in kg. G is constant value, that is 9.8 meter per second square. Now in the first trial, I did 3 trials, and I'm going to put these 3 trials in the observation table. So in the first trial, mass in pen M2, which is M2. When we are going to calculate the tension, we have to use M2 and M1. M1 is our empty pen mass, which is here, already mentioned here. Empty pen mass here, which is 0.02 kg. We are going to use in 3 trials, all the 3 trials, M1 is constant, but M2 value is going to be changed again and again in these 3 trials. So mass in pen M2 is 40 gram. I have put it. So 0.044 kg, which is I have to use in from gram to kg. Now total mass is M1 plus M2 0.06. I think you got at my point how I calculated this 0.06 kg. So M1 plus M2. M1 is here 0.02 kg and M2 is our 0.04 kg. When we are going to add these two values, so we got 0.06 kg. Now tension, how I have calculated tension. So tension's formula is already given in the observation table. Here it is. Total tension. Tension T is equal to M1 plus M2 into G. G is our gravity of mass. So M1 plus M2 is 0.06 into G. G is 9.8. So total value of tension is 0.588 Newton. Number of loops. So which loops I'm talking about? Number of loops which is given in the diagrams. So these loops I'm talking about, these 3 loops. So when I have used the length 40 grams in this, so these 3 loops are created on my string, and I'm talking about these 3 loops, and I have to measure the length of these 3 loops also, so which is used in the further calculation. Number of the loops are here is p is equal to 3, and the vibrating length of these loops is 60 centimeter. Total is 60 centimeter. And when you are going to measure one by one each of them, so length of the one loop is 0.60 by 3.20 meter. How I have calculated this length of one loop? So the formula of the to calculate one loop length is L upon P. L is vibrating length, which is 0.60 m, and divided by number of loops, which is 3. So how you can calculate the frequency? Frequency formula is F is equal to 1 upon 2L into square root of tension upon per m. Now M is already, I have told you that how you can calculate. M is mass per unit length, 0.001 kg meter. When you are going to put all these values in this formula, you can easily going to calculate frequency. 1 upon 0.40 2 L. L is this 0.20. When you are going to multiply this with 2, we will go, we are going to get 0.40 into square root of T upon M. Now T is here 0.588 Newton and M is given in the here. It is constant. And when you are going to calculate these two values, 2.5 into square root of 5888 value is 24.25, which is approximately equal to the 60.6 hertz. Now, how you can going to put these values in the observation table? So let me tell you how you can calculate. So here it is our observation table. In the first trial, we put mass. How much mass? M2. We have to be put here M2. M2 is our 0.04 kg. So we are putting all the values in kg. So we have to mention the unit also. See, kg. I think, yeah, kg. So 0.04 kg we are going to put here. Now we don't need to write again and again kg. We already have mentioned in the upper of the column. So now we have to calculate the total tension. Total tension is our 0.06. That is already mentioned here. 0.06. Where it is? Here it is. Tension, yeah. Tension is 0.06 into 9.8 into. So we are getting the 0.588 Newton. We have to put here 0.588. So the value. So I have already written these two trials. I'm going to fill now the last one. The last one is M2 is 80 gram, which is 0.08 gram, 0.08 in kg. In gram it is 80 gram. Okay, so now total tension is about 0.980 Newton. 980 Newton. Now we are going to check. When I increase the mass, so the number of loops is automatically increased. That is, first, when my mass is around how much it is 40 gram, so loop will 3. When my mass is increased, so loop will going also increase. When mass is 80 gram, so loop will put 5. That means the frequency is going to change according to the weight. So now it's 5, and length of the thread. Now length of the thread is 1. So first the length of the thread was is 60 centimeter. Now again for M2 is 80 meter. No, sorry, 80 centimeter. And for the third, when the mass is increased, so the length is also increased, which is 100 centimeter. So when we are going to change in meter, which is 1 meter. 1 meter. So now the length of the one loop here it is also same, because for calculating the one loop we have to be calculate this with this, and we are going to calculate with the length of the thread divided by the loop, it will automatically 0.20 meter. You have to mention the unit also here. I haven't mentioned. You need to mention. Okay, so let's move to the frequency for the third trial. But for the third trial, the frequency is 62.2. You have to be right over there, 62.2. 62.2. Now, the mean of these all frequency f1, f2, f3, which is I have mentioned here, f1 plus f2 plus f3 divided by 3, because we have did the 3 trials, so we have to be divided by 3 trials. So when you are going to calculate the mean frequency, you will get, see, 60.6, 62.5 plus 62.2 divided by 3, which is 61.8 hertz. 61.8 hertz. You have to write here 61.8 hertz. Okay. So now you have to be calculate the error also, percentage error. Now how you can calculate the percentage error? So the formula of the percentage error, I'm not going to write here. I'll tell you with my own self, which is actual value. Okay, let me write it here also. Actual value minus observed value, observed value, so, and divided by actual value, and these all things you have to be do in the modulus. Okay, you have to be do in the modulus, so value will be automatically positive, not going to be negative. So how you can calculate it is equal to actual value is our 50 hertz that I already mentioned in the starting of the video. Actual value is our 50 hertz. Let me write in the modulus also. 50 hertz minus observed value is 61.8. 61.8, and we have to be divided by actual value. Actual value is our 50 hertz, sorry, 50 hertz, and mention the modes also. So let me calculate here. 50 minus 61.8 is equal to divide by, you have to be divided also, no, with the 50 hertz, and it is 0.236, which is very less, 0.23. Okay, now you don't need to be write mention the minus, because we are doing all the calculation in the modulus. In the modulus, all the, when you are going to do the modulus, so all the value is in the positive, going to the positive. Okay, so it will be 0.23. This is very less as compared to the, so this percentage is very less, 0.23 percentage. Okay, so thank you for watching the video, and sorry for the watermark, because I don't have the subscription of the paid screen recording video, so sorry for the inconvenience, and thank you for watching the video.